So in the last problem of this homework assignment, we're going to take a look at the complexity of parsing certain strings of input under certain grammars. Is it the case that certain grammars are more difficult to parse with the algorithms that we've given? Is it the case that certain strings are more difficult to parse with the same algorithms? And just in case it wasn't clear, this is definitely a challenge problem and very, very difficult. So please don't be upset if you weren't able to get a good solution. If you did get a working solution, I hope you shared it on the forums with your fellow students and discussed how you got there. So to recap, we're trying to answer the question, how much work is it to parse? And before we answer that, we need to decide in some way to measure this work. We could take the time that it takes to run the parsing, maybe measure in seconds or minutes. We could take the energy. When you have a web browser and something like my phone, then we need to decide whether or not our web browser is efficient enough not to drain my phone 4 hours into the day. I'm sure that's happened to some of you before. So this might be measured in watts or some other measurement of power. There's something wrong with each of these forms of measurements, and that is it doesn't really get at the algorithm. If I buy a faster computer, does that mean my parser is better? No. If I build a more energy efficient phone, does that mean the parser is better? Not really. So measuring in such units would imply that our algorithms get better over time, as the hardware does. But the truth is, many algorithms haven't gotten better since when they were first developed in, say, the 70s. So we want a unit of measurements that isn't dependent on the hardware we're running on. That way, if I test my parser, I can compare it to your parser, even though it's very unlikely we're running the exact same computer. Instead, we're going to define our own unit of measurement. For now, let's call it a work operation. We're going to count the number of work operations it takes to parse a given list of tokens, a given string, in our grammar. For this problem, you are asked to give two things: a grammar and a list of tokens that takes at least two x work operations to parse, where x is going to be defined as the maximum number of input tokens, or the size of the largest grammar rule, or the number of rules. So why is this definition special? It means that we can't just give a really long list of tokens and expect to reach 2 times what is essentially x cubed work operations. We have to find something that, given the relative size of the grammar, the tokens, and the rules, is more work to parse. The key to solving this problem is actually ambiguity. It turns out ambiguity really slows down the parsing process given the set of rules that we've defined for parsing a given list of tokens. So let's look at a really ambiguous grammar. This grammar matches a sequence of x's, but because of this rule right here, it's very, very ambiguous. As it turns out, that if you have 15 or more x's in a row, you'll actually break the 2 times x cubed mark for parsing. But for the sake of demonstrating this, I'm going to just show you what the parse chart looks like with 5 x's. So here I've taken the code given in the problem, uncommented the section that prints the chart, and I've run the grammar that we had on a string of 5 tokens. The result is as follows. Right from the get-go, there's a lot of different rules that we can match. And with every step, we keep getting more and more possibilities due to all the ambiguity. Everywhere that we could possibly have a p, we're putting in 2 more p's, and then from there, even 2 more p's. As it turns out, for n characters, we get about n squared possible parse trees. And that means the size of our chart alone includes a lot more than the possible parse trees, and we do a lot more work operations as we try to go through that. So by the end, we've done 3,237 units of work. Now, if we increase the number of tokens to something like 50, we get a very long parse chart. And I'll just keep scrolling until I hit the bottom. It gets longer and longer and longer. And oh my gosh, does it end? Here we go. Yeah, it gets pretty big. Oh, one thing to note that I didn't do in my examples was that the length of your input needed to be greater than 10 and less than 50. And by input, I mean the number x. So here I had x as 50, and before I had it at 5, but that's why neither of these were accepted. So if you did something, say, 11, you would get a success that encourages you to copy it down and submit it. I hope you had fun doing this problem. It's a bit more creative than what we've had in the past, and there's many, many right answers. I hope to see some of those answers on the forum. Until then, bye-bye. I'll end with a smiley face.